let me start the recording before the lecture. Bismillahirrahmanirrahim. Dear student, inshallah today we will learn that how to develop the table of forces. Actually, the table of forces mean that we want to determine maximum internal resistance in each member of truss so that we can design that truss for that particular internal resistance or the force which is developing in that truss. So in our previous lecture, yes, I will quickly give you the overview. So in our previous lecture, what we have done, we have considered suitable live load and dead load which might be acting on the truss, and then we have analyzed the truss or we have converted this distributed load into the panel load. Panel load means these are the load which might be acting at a panel point or at a joint. So I explained you that how to compute panel load and what will be the magnitude of each panel load with reference to interior truss and exterior truss. So I explained that for the gravity panel load, it is acting in the gravity direction. That is the might be summation of dead load or live load, or we can deal the live load and uh, dead load separately for the truss analysis. So we have determined that panel dead load and panel live load in our previous lecture. So this is a typical interior truss. So panel load will be having full magnitude acting in the interior panel point or the interior joint, and half of the panel load is acting at exterior joint. So what is the definition of the panel load? Panel load is the point load which might be acting at the interior joint of interior truss. So depending upon the location of panel point and the truss, we know the magnitude of panel load. So similarly for the wind load, so wind load is acting perpendicular to the panel or perpendicular to this top chord. So this will always be inclined load. So with reference to the interior joint, this load will be half, and at interior panel point, this load will be full or unit load. So this is the panel wind load. So at the interior panel, so the full load will be acting maybe one, and at exterior panel point, half of the wind load might be acting. So we don't need to consider the wind load on this side because wind might be blowing from one surface. So which is the windward, the other side will be leeward. But anyhow, we need to consider another load analysis if the wind load is acting from other side. So this is the panel load for exterior truss. For the exterior truss at interior panel point, half of the dead or live load might be acting panel load, and quarter of the load is acting at exterior joint. If you will just review the previous lecture, you will have the idea again. So then these are the brief overview what load we have considered, and then we have considered self weight of truss by Thai formula. We computed dead panel load, which is distributed dead load multiplied by panel length into spacing of truss. Then we have computed panel live load by multiplying the snow load with panel length and spacing of truss. In the same way, we have computed levered wind load, which might be acting on the leeward side, which is uplift. And then we have computed two wind load, because if the inclination is between 20 to 30, then in that case we might have two type of the wind load 1 and wind load on windward side 2. So depending upon the angles we have computed. Okay, next is table of forces. So in table of forces, I told you that we have to analyze the truss for different load combination. So load combination means that all type of the wind load, live load, and dead load, they may act on the structure with different combination. So actually, depending upon the severity of the load, we have to consider the wind load. For example, in general, we have to use three load combination, and three load combination can further be divided into five. Number one load combination is 1.2 dead load plus 1.6 live load plus 65% of wind load. The wind effect is small and it may be ignored, especially if suction is present throughout. Actually, this is the gravity load combination. So when a gravity load is acting, then the effect of the wind load may be very small. So it means that we can ignore this wind load. So I will give you the example why we may ignore, because due to the gravity load, the member tend to bend in downward direction. For example, here you will see due to the gravity direction, this member or this member, for example, this tend to bend in downward direction. But if the wind load is acting on this side, so this member tend to move on the upward side, uplift. It means that wind load effect will cancel or negate the effect of gravity load. So if we want to determine the maximum effect of applied force, so we may ignore the wind load from load combination number one. Which means that from the combination number one will be simply gravity load combination. We are excluding the wind effect because wind effect is very small or it is negative. Actually, this value will be negative. This means that net answer will be less. So 1.2 into dead load plus 1.6 of the live load. So factor of safety is different with the live load, and also the factor of safety is different with the dead load. Okay, let me make sure that I have started the recording. Yes, recording is running. Okay, the second load combination is 1.2 of dead load plus 50% of live load plus 1.3 of the wind load. So actually, if we want to consider the wind load, then we need to reduce the live load. Actually, the wind load will only be effective when the live load will be less. So if live load is 50%, actually if the structure live load means that actually in this case we have considered the snow load. So snow load will be more in our winter case. In summer case, we might have this self-weight, dead load is self-weight of the truss and the component which is resting on the truss. And in case of the winter, sorry, summer, we may not have wind. It means that our structure roofing system will be lighter. So in that case, if the wind is blowing, the effect of the wind is more on the lighter structure. So it means that when we are having full live load, then wind effect is negative. But if the live load is less, then if the wind is blowing at high velocity, then the wind can blow out the lighter structure portion. So that case, this is the combination that we might use, for example, in winter, but in summer or in maybe when very high wind is blowing, so effect of the live load will be lesser. So we have to consider the possibility of all type of the load which may occur. So all load cannot, the maximum magnitude of all the load cannot occur at the same time. It means that you can say that why we are not considering this 1.6. If we are considering this point as 1.6, then it means that this is the unrealistic case. So that might be unrealistic case. So our structure will become uneconomical because we have considered very large magnitude of the load. It means that in that case we have to consider some realistic load combination. So these load combinations are based upon our experience and the judgment, engineering judgment. So actually here, in this case, we might have two wind loads. So actually the wind might be blowing from the right side or might be blowing from the left side. So it means that there is a difference. Why there is a difference? Because in this truss, for example, here I will show you this wind load case. If the wind is blowing, for example, from this left side, then this case node may be same if the wind is blowing from the other side. Why? Because if the wind is blowing from this side is hinge and this side is roller. It means that due to wind, this edge can slide and when the wind is blowing from the other side, then the forces in other side may be different because this edge cannot slide and now this edge can slide. So what I want to say that if you are considering, let me compare the both case, then it will be give you the better idea. So let me compare these cases just for your understanding. So in this case, I have to make two trusses. Just for your clarity. So let me delete this panel load. Okay, here I'm having two cases side by side. So actually both cases looks identical. You think that when the wind is blowing from this side, then the force produced in this member will be same as of the force produced in this member if the wind is blowing from the other side. It means that you are thinking that you don't need to perform the analysis by considering the wind blowing from the other side because it's identical. If the wind is blowing from the left side, so the force in this member will be same as of this member if the wind is blowing from the other side. That may only true if the both ends are hinges or roller. But in this case, one sport is roller and other sport is hinge. So it means that if the wind is blowing from this side, so this side will be more rigid and this side will be less rigid because this can slide. So the force in this member when wind is blowing from this side will be different as of the force in this member when the wind is blowing from this side. So what I believe that force in this member will be less in this case as compared to the force in this member when the wind is blowing from the other side. Because this edge can slide half of the truss but other end may be rigid. This means that you need to perform two wind load analysis by considering the wind is blowing from the hinge side and wind is blowing from the roller side. So in this case, we are having two load combination, which means that we need to consider two wind load cases. One wind is considering from the leeward side and one wind is coming from the left side. So two analysis will be there. And then similarly, we are having the third load combination. In third load combination, so it means that if we are not having any live load means that this might be perfectly summer season and here also the full dead load is not acting, maybe during construction phase. So in that case, our truss will be the lightest truss, so the wind effect may be more. So it means that we need to investigate the truss also for this third load combination. So third load combination is further divided into two parts. In one part, wind is blowing from the one side, and other part, wind is blowing from the left side or hinge side. So here you can write that right may be the hinge side, left may be roller side, or vice versa. So in total, we are having one, two, three, four, five load combination. Actually, not five, maybe nine. Why there will be nine? Because I will explain. There will be nine. The load combination will be only five if we are having one windward load. Actually, we are having one leeward load but two windward load, which means that our load combination will be in fact nine. So I will explain. So actually, we do not perform the analysis of the truss for this complete load. For this complete load mean that after getting this total magnitude of the load. So actually, if we know the analysis of the truss due to this moment and due to this component and to this component, if we are adding up, the amount will be same. So actually, by principle of superposition, so simple of superposition mean that the effect of the resultant force will on a structure will be equal to the effect produced by component of the force. So in other words, what I can say, let me write the condition over here. So you can say that a simple, if we are having a constant a, and if it is multiplied with x plus y value, this will be equal to ax plus ay. It means that whether you are multiplying a constant with a summation of the two forces, or you are multiplying the constant with each component of the load separately, then you are adding up. Answer will be remain same. So the how I can explain is mean that if on a truss or in any member a force of total 10 kilonewton is acting, so we can determine that what is the reaction in the member. So this reaction is computed if we know the a reaction due to the force of 4 kilonewton and due to the force which is acting as a 3 kilonewton. So effect which is being produced by a force of 3 kilonewton, if it is being multiplied with the 2 and then added up plus 4, then it will be the total effect. So what is the principle of superposition? Superposition means that if I can consider this force as a P into 1, P multiplied by, you can say that it will be 1. And this will also be equal to P multiplied by 1. And this factor will also be equal to, you can say that P multiplied by half. In the same way, this will be also. So actually what I want to do, now I will make a duplicate of this slide. Instead of analyzing a P load, I am analyzing this stress for a unit load, one load, simply. So due to this one load, force in any this particular member, let me, it may be, you can say that 5 or maybe 2.5 Just example, 2.5. In this force, the force is coming as a 2. Okay, bottom chord, this one. Okay, and then if I am analyzing this truss for a unit load, maybe 1, then the force in this member will be 2.5. So that will be same if I have analyzed this force as a P. So if I will analyze this force as a P, then force in this member will be 2.5 multiplied by what is P? So it means that if I have analyzed this stress for a load 1, so I don't, if I know the reaction in this member due to the force 1, okay, sorry, gentlemen, I have to take call, was equal to 1. So it means that if I know the panel load, so I can simply multiply the reaction in any member with the panel load, so I will have the corresponding reaction. So why we want to analyze the truss for the unit load? Actually, we are having separate dead load and separate live load. So it means that we don't need to analyze the truss separately for the dead load and for the live load and for the wind load. If we know the truss analysis, for example, in this case, so if I know the forces in each member of truss due to unit load means 1, then if I want to convert this reaction into the reaction when a dead load is acting, dead load means that if all this load will be PD, PD means that panel dead load. So in that case, panel dead load. So in that case, means that all are, this is also PD, this is also PD, this is half PD. So then this force will be equal to 2.5 multiplied by P sub D. So it means that I can perform the analysis only for a unit load. Then if I want to convert the reaction in any member due to the panel dead load and live load, I can simply multiply the force, the reaction in any member with that load. So it means that we need to carry out unit load analysis for this truss. Unit load analysis means that you will consider the load acting on each panel as a 1. So today I will assign you one truss. You can perform this analysis for your truss. So for the interior truss only, for the interior truss, you will perform the unit load analysis. Unit load analysis means that you will assume that the truss is subjected to one load. One load means that that might be live load, that might be dead load. So interior panel point or joint will be subjected to load 1, and exterior they will be subjected to load half. So this will be your analysis 1. Unit load analysis for gravity load analysis for unit load. So here you can say that this is gravity load analysis for unit load. So how you can perform this analysis if you are given the truss? So actually the truss that you will be given may have many members, maybe more than 20, maybe 25. So you can use any software, tab, eTab, or there are many online free software available. Free online software are available on maybe on internet. Just Google it, just write down free truss analysis software online. You can download even, or you can perform the truss analysis by online. So one of these software, I can maybe write down the name, maybe Sable. So there are other many software available. So just for example, I'm writing here the Sable. Sable is the one software, but you can write on the Google. So they are very easy to use. You just need to learn, and you need to just read the instructions. So you can construct a truss and you can provide a load, one load on the interior panel and half load at exterior joint. So in the same case, you need to carry out the two wind load analysis. Two wind load analysis, one for the right side of the truss and other for the one is not copied. So here that will be one. So for the wind load analysis, you need to consider the load acting perpendicular to the surface. So this load will be half. And similarly, this load will be half. Why this load? Because no panel is available on this side and also no panel is available on this side. So this joint is surrounded by the panel on the both sides. Similarly, you will perform the wind load analysis by considering the wind is blowing from right side. That you may refer maybe wind side or leeward side. So you have to perform two analysis. Okay, if the wind is blowing from this side will be the windward side and this side will become leeward side. If the wind is blowing from this side, that side will be the windward side and other side will become leeward side. Actually, now I want to explain that on any software, most of the software that you will consider, that you will maybe see on online, maybe ETAP, there is no any option to provide the, you can say, inclined load. So in that case, what you can do, you can convert the load into two components. If you know this angle, you can also know the inclination of this. So what you may do, you can convert this inclined load into two components, and each component will be acting in horizontal and vertical direction. So just for your clarity, I'm changing the color. So here you can replace this load, this green load, in with the two load. One is the horizontal component, and one will be the vertical component. Here you can replace this load. This component will be computed by considering this load as a one, and similarly you can consider two components over here, and similarly you can replace the green load by two components, because if you know the inclination of this, then you can this inclination and this inclination will be same, so you can convert this load into two components. It means that that load will be one, that load will be one for the wind load, unit wind load, that is also you are performing for a unit wind load, that will be 1 by 2. So in total, you need to perform three analysis of the truss for unit load, two analysis for unit wind load, and one analysis for unit gravity load. And then if you are applying this unit load on the other side, the right side, so you are having three analysis. Okay. Okay. Next is here you are having table of forces. So this table of forces is also given in your book. I am having the third edition. Some of the students, they might have fourth edition with them. So on page number 267 in book, and it is a table 7.2, which is referred as a table of forces. So actually, what is this table of forces? From this table of forces, we are interested to determine maximum compression or tension which is being produced in any truss member due to the 5 load combination that I have explained in previous slides. Okay, here, what you will do, you will have, for example, this truss. In this truss, you can give the number. This is the member number 1, member 2, member 3, this is member 4, this is member 5, 6, 7, 8, maybe 9, 10, and onward. So you can give the number to each member, and then you can write down the length of each member in the second column. So I have just shown you 2 rows. So a complete table is given maybe on page number 7.2. I will also show you a typical table for the calculation. So then in the in the third column, you will write down the forces in each member when you perform unit gravity load analysis. Unit gravity load analysis means that when you perform the analysis for this case, unit gravity load analysis for unit load. So you will consider force on interior panel 1 and at exterior panel point joint half. And then due to these forces, you will analyze, you can analyze manually by method of joint, method of section. But I will recommend to maybe learn how to perform analysis on SAP software, ETAB, or any Sable or any software which are online available. So you just need to attach the report along with. So you can consult anyway. So due to these forces, you can determine the internal force in each member, and then you may write the forces due to the unit gravity load in this column. Then member force due to unit wind load on hinge side. Hinge side, you can consider this is the left side. In my case, I have considered the hinge side on the left side. So you can say it's the left side or the hinge side. So due to this load, half, 1 and 1 by 2. Instead of applying the inclined load, you can convert this load into 2 components, horizontal and vertical. You can apply 2 loads and you can determine internal forces in each member of truss. And then you may write these forces in column number 4. And then in column number 5, you will perform another analysis for unit wind load, but now the wind is acting on the roller side or on the, you can say that, right side. Okay, now in column number 6, I am using this load combination, this load combination. So I am having, I have already computed PD and PL. So this means that I have to take the one, I need to multiply 1.2 with the dead load and 1.6 with the live load. Okay, here, how I have computed. Panel load, dead load and live load you have already computed. Just see in the previous slide, in the previous lecture, we have computed panel dead load and live load. Okay, both loads, they are gravity load. So dead load is 7.04 and live load is 8.25. So I need to multiply this dead load with 1.2 and this load 1.6. It means that I do not need to perform the truss analysis separately for 7.04 dead load and 8.25 live panel load. So now because I know I have performed the analysis for unit load. So whatever are the forces in member due to unit load, if I will multiply with the dead load, so I will have the escalated response. Or it means that is simple example means if price of one chocolate is 10 rupees, if you are having 100 rupees, how many chocolates you can buy? 10. So the response will be increased by multiplying the force which we are having instead of a unit force. So see here, 1.2 panel dead load we have already computed. Live load we have also computed. We have multiplied with 1.6. And I have taken the sum of dead load, live load, and summation of this load is multiplied with column 3. What is column 3? Gravity load. So it means that if this member force is equal to 1 due to unit load. So what will be the reaction, or what is the force in that member when this load is acting? Simply, this entire constant is equal to A. So A, this is x, this is plus y, this is a constant A. So it means that if we multiply this 1.2 dead load plus 1.6 live load with column number 3, so we will have the total reaction in each member when a gravity load is acting. Okay, in the same way, first I will show you the back this load combination. So in this load combination, I have to consider two loads. So uh, in the same way, let me summarize over here. Maybe it will be better to get the idea so that you will not confuse. I would like to write down within bracket. Here, let me write wind H. H means, or you can say right or left, when the wind is blowing from hinge side. So this load combination I have to use. So in second case, here I have to use this R. R means wind is blowing from roller side. Actually, load combination number two is further split up into two load combination. Okay, here this will be the gravity load. It means that for this case I have to use unit gravity analysis. But here, if I want to compute this component, I have to consider the wind load analysis when the wind is blowing from the hinge side. And in this combination, I have to use the wind load analysis when wind is blowing from the roller side or on the right side. So similarly, we will have this load combination. So let me also modify over here, or maybe I just can simply copy from here. Okay, changes, no problem. So that will be, so this will be 0.9. So this will be our load combination number 5, which in fact, now I will be able to explain from the couple of courses. Now in this table of forces. Just understand what is WH. H means inside and this is roller side. Okay, just see now table of forces. So here in table of forces, 1.2 PD plus 0.5 PL, this multiplied by column number 3 because unit ordinality. Then 1.3 multiplied by PWW plus into column number 4. What is the column number 4? When member force due to unit wind load plus 1.3 PWLL multiplied by the column number 5 when the wind is blowing from the leeward side. Okay, here, while we are having this both case, I need to explain again. I told you that in this case, actually, this is a very important point that you need to understand. So when a wind is blowing from this side, actually the total wind is acting like this way. Or let me show over here, because either you will show here or here, that will be the same, because we can move the force in its line of reaction. Actually, if the wind is coming from this side, so top member are subjected to downward force, and the sum of the wind may go inside the building because wind is coming from this side. So that force will produce the leeward forces on this side, uplift effect. Actually, windward side and leeward side are subjected to wind force simultaneously. So actually, we have already performed the wind load analysis for the leeward side. For example, this case, if I multiply these forces by -1, these forces, then this forces will become this one. -1 means that will become opposite. So actually, you have already performed the leeward load analysis for this case. So actually, if you are multiplying this gravity, this wind load analysis by -1, so that -1 is equivalent to these forces. It means that summation of, you can say, this force analysis plus, if you multiply this analysis of this stress by -1, that will be equal to total this analysis. So actually, you just have performed unit wind load analysis on the windward side and for the leeward side. So you don't need to multiply the forces in each member with -1 because you have already computed PWLL as a negative upward. Which means that whatever the wind load analysis you are having for a downward wind load, if you are multiplying with this PWL, so it will automatically convert the effect in the outward direction. So what I want to say that again, when the wind load is acting, so total wind is like this way. We are also having the wind from the windward side, and we are also having the wind force in the leeward side. So it means that if I multiply this, I can split up these two forces into these two components. So if you multiply with -1 and add with these forces, so this will be equal to this resultant forces. So actually, you have already multiplied this wind load analysis with negative. So it means that effect of the wind load analysis when you consider the wind load on the leeward side will be same as of if the force is acting on the upward side. So this is the total wind load, but we have split up into two parts. One part wind is acting on the windward side, other part wind is acting on the leeward side. If you multiply with -1, that will become opposite. But you don't need to multiply with -1 because you have already considered leeward force as a negative. Okay, here that's why your load combination will be this one. So 1.2 plus PD plus 0.5 PL multiplied by column number 3 gravity load, then 1.3 panel wind load multiplied by column number 4. Column number 4, because both forces are acting at the same time. Column number 4 is wind load analysis that you have performed considering the wind direction from hinge side, plus 1.3 of the levered wind load panel load that you have computed multiplied by column number 5. Column number 5 means if the wind is coming from the leeward side and PWL is already having negative sign, so it means that that will have the uplift effect. Similarly, in column number 8, so we have to reverse the wind load analysis. Reverse means that we have to assume that wind is coming from the right side. So if the wind is coming from this side, so this side will become wind load and this side will become the leeward load. So that is the exactly mirror image of each other. So simply what they have done, this factor will be remain same. Now 1.3 windward, it is multiplied with the column number 4. Column number 4 before, sorry, 1.3 windward is multiplied with column number 5. What is column number 5? If the wind is blowing from the other side. So this side will become windward and this column will become the leeward. So it means that now the leeward force is multiplied with column number 4. If the wind is blowing from this hinge side, this will be the windward and this factor will be used for the leeward. If the wind is coming from the roller side, this side will become the windward and this side will become leeward. So just we are multiplying the panel windward load with column number 5 and 1.5 of the leeward load with column number 4. What are the column number 4 and 5? These are the wind load wind load analysis for the unit wind which is acting on either side, maybe the left side or right side, that we are referring as a hinge side or roller side. Okay, next combination is simple. This one, in this case, we are only having gravity load is the dead load 0.9 and wind load, which is 1.3. So it means that these two factors they will be repeated. So this is for the first case if the wind is blowing from the column number 4 side or the windward side, and if this is the case if the wind is blowing from roller side, just the top parameter they are changed. Instead of considering the 1.2 dead load and 0.5 live load, we are considering 0.9 dead load being added with the wind load analysis. Okay, now it means that for this same truss member number 1, we are having 5 forces, factor forces. One is due to load combination number 1, one is due to load combination number 2, one due to load combination number 3, one due to load combination 4, and one due to load combination number 5. Here, in the next column, we are writing maximum TU, and here maximum PU. Out of these 5 columns, whichever will have the maximum tension, positive force right here. Similarly, out of this 5 column, whichever will have the maximum compression force, that you need to write over there. So actually now I'm I'm explaining that you need to make two table of such type in your case. Why you need to make this table for two type? Because you are having two windward load. So one table will be for the windward load 1 and one table will be for the windward load 2. Why? Because here if you will see, you have computed two windward load, one PWW1 and one for PWW2. Because we have seen that I have already explained, it was in the previous slide. Uh, so let me open. So here, because I told you that if the lever load will be remain same, but if the inclination of the roofing system is between 9.5 to 3.7, we will have two CQ values. One will be zero point 0.9 outward positive, sorry, negative, and one will be zero point 0.3. So in this way, we have computed what I must say, two windward load. So it means that one table will be for windward load 1 and other will be for windward load 2. Or what you can do, you if you don't want to make four table, just you need to add four more row. Add this four row more. So in this four row, what will be difference? In the first four row, that will be PWW1, 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 PWW1. In the next four row, that will be PWW2, PWW2. This will be also PWW2, and all the other factors will be remain same. It means that now you will have 9 forces instead of 5. So out of 9 forces, report here what is the maximum compression here and maximum tension, maximum tension in this column and maximum compression in this column. Okay, let me show you one. I was having my own sheet, I will find, but this is a sheet that made by a student in the previous class. So I have assigned them a truss. Similarly, I will also assign you, I will send you in the hard form that you can discuss with me. For example, I will assign you this truss. So in this truss, I will, this will be truss, you will have the length and H value. I will assign you what will be the L and what will be the H value. So R value will be your roll number that I will assign you today. So each of you, you will have different length of your truss and different height of your truss. So on the top chord, we are having 1, 2, 3, 4, 5. So if you know the length, you know the height, you can determine this uh, uh, chord, inclined chord. So if you know this total length, divide this length into 5. 1, 2, 3, 4, 5. So you will have this panel point. And then for this bottom, you can divide into maybe 1, 2, 3, 4, and 5. You can say that the length is same for this bottom chord. So you will have this panel point. So it means that if you have this point and then you can join all the other members, you can compute the length of all members. So this point is connected from here to here and this member they are connected. So you can determine the length of each truss member and you can give them the number. You can apply the unit load, gravity or wind load, you can perform analysis. Okay, here now I will show you the you have already computed the wind load. So when I will send you data, I will also give you some theta will be different for all of you, but I will send you this loading. What load you have to consider? Dead load I will send you. I will assign you the insulation load, self weight of the person, miscellaneous and bracing. You have to compute panel length. All of you will have different. You will have different length of truss. All of you will have different spacing. So you based upon your geometry of your truss and the load that I will assign you, you can determine the dead load and live load. In during calculation, you need to compute uh, cell weight also by third formula. So at the end, you will have PD value, you will have PL value, panel dead load, live load, you will have panel lever load, and you will have two windward load, depending upon geometry of your truss. And then you will make a table of forces, just like I have explained. You can make a table on this Excel. So on this Excel, this guy, instead of giving the number to the truss member, he has given the AB. A is a joint and B is a joint. Joint member from joint A to B. He has computed the length of each truss member. Here he has written the force in each member due to the unit gravity load. Some may be negative mean compression in kilonewton. In this column, he has written the member force due to unit load on hinge side or right side when he performed the wind load analysis, just like I have depicted here. This this is on the hinge side, this is on the roller side. You need to convert this load into two components. So here, if I delete this component, actually on truss, total force is acting like this. But we are converting, if I multiply this force by -1, so these forces are also downward. Then I can split up the forces. Once force are only acting from the right side, once the force are only acting from the left side. So this plus minus multiply these forces are equal to this one. But you don't need to multiply this wind load analysis with -1 because PWL levered forces are already having negative sign. Okay, here this is the unit wind load analysis when you consider the unit wind load acting only from the roller side. So he has writing the forces over here. Okay, in these columns, this student he has written panel dead load and live load, and here he has written panel dead load and live load. He has performed the calculation on his design register, just like here. You have already performed, so you are having this panel dead load 7.44 and panel live load 8.25, and similarly levered wind, this is a levered wind load panel load, this is minus because CQ coefficient it was negative. So he has written in this column that he has already computed. So similarly, this is the PWW1, maybe the windward load 1, because we having two windward loads. One is positive, another is negative. So here, after that, what he has done, Just see, this is 1.2. 1.2 mean that he has added up PL with PD. PD is above. After adding up, he has multiplied with the member force with this one. So he is having total force due to the gravity. Similarly here, he has used the formula 1.2 PD plus 1.6 PL multiplied by column 3. 1.3 of this windward load 1 multiplied by column number 4. So actually he is supposed to write here column number. So it is better to add a row over here. Maybe just to give the numbering to the column 1, 2, maybe 3. So that you will have the idea which is column number 1, column number 2, 3 and 4. So he has completed this table. And then in this you can use the command maximum. So maximum wind load and the live load you can compute over here. So at the moment, gentlemen, I would like to give you a break and I would like to take your question after the break. Maybe the break will be of maybe 15 minutes. Maybe I will resume lecture at 2:25. In the meantime, if you will have any question, please write down and you can ask me after the break. Okay, see you after break. Yes, can you hear me?
यस सर मैं इधर ही हूँ।
ठीक है, स्लाइड ये नजर आ रही है स्लाइड, मुझे बताओ जरा। हाँ जी, अभी इसको स्लाइड आ रही नजर। ठीक है, तुम्हारा नेट बहुत स्लो है यार। So any question from table of forces or how to perform unit wind load analysis or for the gravity load. There are many software available online also or the free version. So you can perform the analysis on online software or you can learn on eTab or SAP. Tutorials are available. Okay, here actually this student he has made two tables, separate tables. One table for windward load 1 and one table for windward load 2. So I would recommend maybe table of forces this is 2. Let me do what I am doing. So I am merging the boards. So what I can do, I will. So I will just copy and paste this just to make a one table. So here in this case what I can do, where the wind load is 1, I will just write 1. Leeward forces will be remain same. Then here I will also make it windward load 1. Leeward will be remain same. So I will highlight maybe these are for the windward 1, and this combination might be for, you can say, windward 2. Again, this is windward 1. This is also for windward 1. This is also okay. Now here this will be for windward 2. Aniki, okay, just gentlemen, just hold on. I was just explaining. So this already this is PW2. This will also be PW2. This will also be PW2, and this will also be PW2. It's mean that I am having 4 columns for PW1 and 4 columns for PW2. Okay, let me copy the same formula over here. Let me check in this formula what he has used. So here in this formula, 1.2, so he is a mistake here. It means that this one has many mistakes. 1.2 should be multiplied with the dead load. So instead of this plus sign, it should be carried. Yes. 1.2 multiplied by this dead load, this is H441. So if we are having string on the both sides, so this cell will be fixed. And then it is multiplied with what I must say, zero point 0.5. Okay, F11. F11 means unit gravity load. Next is 1.3 into live load. So 1.3, this should be this one. So this guy is having many mistakes. Anyhow, I will just change the windward 1.3. So instead of this H3, I will make it H4. Similarly here, wherever there is a H3, I will make it H4. So you have to change all these formula accordingly. This is wherever I am in H3, so that will be H4. So this guy he is having mistake. So you can do for your cases. this formula is applied. Anyhow, there is a mistake in this formula that you will correct it, but let me correct it at the same time. So this is 1.2. So he has forgot to put 1.5 PL case. So that will be 0.5 multiplied by this flat, and if I am multiplying the function f4, okay, this will be 6. Actually, this is the correct formula. Okay, he is asking to use one bracket. This is supposed to be H2. What mistake? G11. Anyhow, you can do it. So you have this complete table of forces. Out of this table of forces, what you can do, forget about the stress reversal. So here you have to write down the command maximum. Select maximum, and you need to select the range from this. So the maximum forces will become over here, which is maximum tension. Similarly here, you can apply minimum from 11 to Q11. So the minimum force will come over here. So the maximum tension in different load combination will come in this column, and maximum compression in any load combination will come here. So what does it mean? It means that this member, due to different load combination, it is subjected to, maybe due to one load combination in tension, and due to the wind load combination, it is subjected to compression. It means that maybe in when there is no wind or wind load, then there is the only tensile forces are acting. But in winter, when the wind load is acting on the truss, the same member is subjected to compression. It means that for what force we need to design this member for. So it means that we need to design it for tension or compression. So that we will discuss. So in the remarks, you can write stress reversal. Stress reversal means that this member is also subjected to tension and the compression at the same time. Some member they might have only tension or might have compression. So in the remarks, you can write that tension only or compression only. So any question regarding this table of forces? If you, I believe that you may develop this table of forces yourself. Maybe on the Excel sheet you can develop. So any student who is having the question regarding this table of forces, they can ask me. Otherwise, I will continue to the next slide. Okay, after table of forces, Actually, we will start how to design the purlin. So purlin, I have already explained that purlin is a beam which is provided perpendicular to the truss, or it is a special beam which is resting on panel point of one truss to the panel point of other truss. So it's mean that purlin uh, is a beam which is connecting two panel point of trusses. So what is the basic function of the purlin? Actually, all load, dead load and live load or wind load, actually they are acting on roof sheeting. The sheets may be corrugated that are maybe provided at the top of truss system. So then all these roofing sheet and other, they are connected with the purlin. It means that all type of the load, it is transferred at purlin from roof sheeting. So then what the purlin they are doing, they transfer all load in terms of the point load or concentrated force at panel point or at a joint. So they are preventing any load which is directly coming on the member or in between the truss member to avoid any bending movement. So purlin, they are the beam which is resting the two panel point of trusses, and they are transferring all live load and dead load at a panel point. So these are some specification or design criteria provided by AISC to design the purlin. Purlin design means that how to select the type of the section or and the area of the section for a purlin if we are provided with all the load and span length of that purlin. So AISC has given general specification for this purlin design. So actually for the purlin design, we can use any ASD method or LRFD. So, but for the convenience, in this our particular design class, we will study ASD method only. However, only ASD method is explained here. Service load and reduced material strength are involved in allowable stress design. This means that if in purlin design, what we will do, we will not apply the service load with any overloading factor, but we will only reduce the material strength. So material strength will be reduced by a certain factor, and service load will be used as it without being multiplied with any overloading factor or factor of safety. So it is assumed that the roof sheeting provides the necessary lateral support to the purlin through J bolts, and the purlin behave as a continuous bracing. So I might have some figures. Maybe I would like to show. Maybe not here. Yes. So, and also I would like to open the other slides because it is important to explain this concept. Okay, here we are assuming that this is the purlin actually. So you can assume this is one truss, this is second truss, this is third truss, this is fourth. So a same purlin is running over four trusses or five trusses. Actually, this purlin is a continuous beam. So this is a type of the beam which is used in our truss system, which is placed on one panel point to the other panel point. Actually, if this is a continuous beam, then we assume the internal support as a partially fixed. But for our design convenience, we assume that purlin is simply supported between two trusses. And also at this each panel point, it is connected with this top cord and a roof sheeting with the help of J bolt. So J bolt means just like this. If you can see from the cross section, so this black channel is a purlin. So with the help of J bolt, so J bolt one side is gripping the bottom flange of purlin and the top side is connected with the roof sheet. So it is gripped. So this J bolt is continuously it is connecting this purlin thoroughly along the length. It means that our beam is continuously connected at different intervals with the roof sheeting and the truss roofing system. So in this way, the purlin cannot bend in lateral direction. So in our beam design topic, you will learn that if a purlin or a beam, it can bend in lateral direction. Lateral means horizontal instead of vertical. Then it reduces the capacity. So if beam is restrained to move in the lateral direction, in that case, we can achieve its full capacity. We will learn this thing in detail in our beam design topic. And further, you can see that these are the these holes, these are the bolts, and these are the purlin. So these board, J board, they are connecting this purlin with the roof sheeting along the length. So which are also restraining the movement of this purlin in the lateral side. Sometimes we also use the sag rod. Sag rod are additional maybe transversal beam or the rod which are preventing the horizontal or lateral movement of purlin. For example, here you will see that this is the sag rod which is connecting one purlin to the other purlin. So purlin is in the transversal direction. So this sag rod is provided at the mid-span of purlin to prevent the movement of the purlin in lateral side. So we learn the design also. So these are roof sheeting. You can see that this roof sheet with the help of this bolt, all these bolts are connecting the roof sheet with the purlin. So the load is acting on this top of this roof sheeting, snow load, live load, and then this roof sheeting is connected with the purlin. So all the load is going to the purlin. And the purlin is only connected with the truss. So these purlins are resting on this truss at the panel point. So it means the roof sheet is not in contact the mid-span of this top chord or any truss. It means that all the load is transferred at the panel point with the help of end reaction of this purlin, force reaction, which are considered as a point load. So this load we have already computed as a panel load. Now I will move back to the AISC specification. So this I have mentioned. Okay, further, I told you that let me write over again over here that 5BMN. Okay, maybe you will understand from here. So moment carrying capacity should be less than, sorry, this is applied bending moment should be less than equal to moment carrying capacity. So here you already know that I have explained. Um, do I need to write? Okay, let me uh, add the one slide and just to explain you again. So I already told you that we are having general equation. What is the general equation, design equation? R A should be less than or equal to. You can say that equal to uh, Rn. Okay. Service load should be less than equal to resistance offered by shape of material. So in this equation, in LRFD, so in LRFD, this equation will be if I multiply with the factor of safety F1 on this side and sorry F of just say F1 here and phi value over here. Maybe we may have phi value over here. So this is the design equation in LRFD. So if you are multiplying with F with RA, then this will be converted into RU. So RU is factored load is compared with the design capacity. But in ASD, this equation will be considered same. In ASD, what we do, we use the service load as it, and we divide the capacity by factor of safety that we are referring as a omega. Omega is a constant factor, so we are using this equation. So I told you that in case of the R, there may be tension, compression, or bending moment. So if we know the applied bending moment may be MA. MA means service, which is due to the applied load. So here we are referring as a MB. So we know that the stress is equal to, stress we show by F is equal to M Y divided by I. Or we can write like this, M over section modulus. So Y over I over Y is called a section modulus. So from this equation, if this F is equal to FB, bending stress, so it means that from this, if Mn will be the moment carrying capacity Mn nominal, because I want to compare with the applied bending moment. So it means that if I know the material strength in bending and section modulus, I can compare Mn. Or Mn will be equal to, this will be equal to Fb multiplied by section modulus. So this will be the our equation. So it means that this is Mn will be the plus. So here, what I want to do, I want to compare Mb with Mn. Or here, let's put MAB, I'm writing MA. MA is moment, applied moment that I have compared to this service load. So MA should be less than Mn equal to sigma. So this will be my equation in ASD. If I substitute the value of Mn here, so this equation will become like this. MB or MA will be equal to FB and Z elastic section modulus. Okay, here actually S is elastic section modulus, but X is denoting that is the section modulus about x-axis, because section tend to bend in x-axis. So just like I have explained that if a beam is continuously braced, any beam, continuously braced means that I have told you that purlin that is thoroughly connected with the roof sheeting with the J-bolt. So there is no any chance of lateral buckling. So if any beam is laterally braced, then its capacity is increased. We can say that since it cannot move in the lateral direction, so it can take more load. So in that case, actually we are using the plastic section modulus, ZX. So ZX is partial section modulus or complete section modulus. So that is at the moment is difficult to explain, because we will study in our bending, in our what I can say, in our beam design chapter. But here, what we do, if we are using this equation and we assume that instead of the S, we have to use the ZX, because our section will be plastic, because it will locally yield and it will not buckle. And we assume that ZX is difficult to determine. So ZX is equal to 1.1, or it is 10% more as compared with the SX or elastic section model. So our equation will become this one. So MB is the bending moment which is acting on a beam or on a purlin due to service load. So you can write also A. So A is due to service load. So in order to compute this bending moment, we haven't multiply the applied load with any factor safety. So FB is the material strength. So we can, what we can do, we can further modify this equation. 1.67 is the factor of safety in ASD, which is 1.67, you already know. So here we can say that MB is the applied bending moment, applied service bending moment, and FB can be equal to, sorry, there is a slide, and FB we can say that that is the FY. If we know the material strength, then we know the applied bending moment, then only unknown will be the section modulus. So if section modulus is unknown, so we can determine what is the minimum section modulus required. So I can modify this equation further. So Sx will be equal to maybe MB divided by, first multiply by 1.67 and divided by 1.1 into Fy. So we know, if we know the applied bending moment, we know the material strength, we can determine what is the Sx required. So we can easily determine this value. So from this section properties table, we can compute Sx required. Okay, now I will be able to explain here. So MB is equal to the service bending moment which is applied, FB, Zx, omega, FB. So you know that 1.1 divided by 1.67 will be equal to 0.66 Fy. If this is 1, then 1 divided by 1.67 is equal to 0.6. So already computed here. Sx is the section modulus, FB are bending stress. So FB are equal to allowable bending stress. In ASD, the bending stress in our purlin should not be more than 66% of Fy. So allowable tensile stress is Ft or 0.6. In bending case, 0.66. In tensile case, we have already used in our yielding criteria already. So next point is that dead load and live load combination is used because it is proved to be critical for purlin. So for purlin will not be designed for any wind load combination. Because for the wind load combination, if the wind load is acting along with dead and live load, so wind load will negate the gravity effect. So load will be lesser. So purlin will only be designed by considering dead plus live load or gravity load combination. This I have already explained. Dead load on the purlin acts due to roofing, insulation, and self-weight of the purlin. So when we are designing the purlin, on the purlin, what are the components which are attached with the purlin? These are roof sheeting, insulation panel, and self-weight of the purlin. Self-weight of the truss is not acting on the purlin because the self-weight truss is on the downside. Self-weight of the purlin is acting on the truss, but the self-weight of the truss is not acting on the purlin, just like here, because purlin is above. So weight of the truss is not acting on the purlin. So insulation load is considered if it is directly attached or hang with the roof sheet. So we are assuming that if we are to use any insulation panel, it is directly attached with the purlin. So approximately 1/3 or half of the miscellaneous load may be included. Actually, in order to compute the panel load for truss, we consider full miscellaneous load. Miscellaneous means that these are the load of the nuts, bolt, washer, and the other things. So these nut bolt and washer, they are include the bolts which are also used to connect the truss member. So it means that we many bolts and are not used on our purlin and the roof sheeting. Maybe half of the bolts are used to connect the truss member with each other or with the gutter plate, and half of the bolts, nut, washers, and all the other things they are used to connect purlin with the roof sheeting and truss. So in that case, what we do, we may consider miscellaneous load as half or one third of total miscellaneous load. So these are the total load which are acting on purlin. So these are some other conditions. Actually, purlin is a beam. So in the beam, we need to control the deflection. The deflection in the purlin should not be more than certain limit. So this parameter can indirectly be controlled at the start. So actually the deflection is the inversely proportional to moment of inertia. More will be the moment of inertia, less will be deflection. Because you already know that, for example, in the cantilever beam, the deflection formula is PL cube over EI. So I value is directly proportional to depth because moment of inertia is B d cube divided by 12. So it means that we are keeping the d value or depth of the beam more than some minimum value. It should not be less than certain limit. We set already at the start. If the depth will be less, so there are chances that the beam will have large deflection. So at the start, we can control indirectly by keeping the minimum. S is the span of purlin. So span of the purlin is equal to spacing of truss divided by 27.5. Length of the purlin divided by 27.5, that is the minimum. So depth should be minimum equal to this value or it should be more than this value. So we will have to make sure. Actually, in the previous code, what we need to do, first of all, we have to, when we are going to design the purlin, we have to move some chronological order. For example, first of all, we try single angle without any sag rod. If it is not satisfying, then we go for single angle with one sag rod, with two sag rod, and then we are moving from the channel. But now, in the latest specification, the design of the purlin has made it very simple. So what is simple? Depending upon the inclination of top chord, we can decide that how many sag rods are required. So what are sag rods? I told you that these are the rods which are providing the lateral bracing to our truss so that it cannot deflect in the lateral direction. So uh, let me show you the sag rod also. Okay, you can assume that this is the only one truss and this is another truss. So this is sag rod. So sag rod, they are connecting the top chord and the top purlin and with the bottom purlin. So each sag rod is connected with the help of J bolt and sag rod is constraining the movement of a beam or this purlin in the lateral side. So if we are not using the, actually they are controlling the deflection in the lateral side also. So it means that if we are not providing the sag rod, then we need to select a very heavy section which may have very large moment of inertia also in the y direction. So to make the design economical, we select a lighter section with the combination of sag rod. Sag rod may be provided only one sag rod at the center or two sag rods, one at each one third point. So at the start, we can take the decision about the sag rod. So first of all, first decision will be if the inclination of top chord is less than 15 degree, no sag rod is required. If inclination is between 16 to 25, we have to use one sag rod. And if the inclination is more than 25, we have to start the design with two sag rods. And angle section, first of all, we will, let's suppose, if our inclination of top chord is 20 degree, then we will select one sag rod. First, we will design this single angle section as a purlin with one sag rod. If this design is not satisfied, heaviest angle section even it is not satisfying, then we consider the channel section with one sag rod. And actually you can try all the three options. You can design single angle with one sag rod, you can design single channel with one sag rod, and you can also design W section with one sag rod. And out of these three options, whichever will be the lighter one or the lightest, you can use as a purlin. Actually, if you are using this single angle section, then width of the single angle should be less than 102. Why should it be less than 102? Because okay, let's go if you are assuming this purlin. If the width will be more, then the centroidal location, because centroid of the angle section is outside, then it is having large lateral effect also. Because some of the force is because when the purlin is inclined, so it will have one larger component which is acting in the lateral direction. So lesser will be the width, closer will be the centroidal location to this vertical leg. If the width will be more, then the centroidal location will be more away from the vertical leg. So it will have more lateral deflection effect. So Z section behavior wise is the best section for the purlin. Z section you will study in maybe mechanics of materials. So Z section is the lightest option available. So Z section is normally these are made of the cold work section or thin wall section. Next, in case of section modulus required for the first option is greater than 230 into exponent 3 millimeter square, then option of channel section may be selected directly. We say that first we will compute the section modulus uh, of required section modulus for a single angle. If section modulus is more than 230, we will not select the angle section. We will directly select the C section. Because if the section modulus is more, so single angle section will not be good for purlin. Width of the angle section may not be more than 102. I have already explained. The roof load is converted into the beam load per unit load by the following formula. Okay, all load which are acting on the roof sheet, on the purlin are the roof sheeting, dead load and live load. So these are the aerial load distributed over the area. So if we are multiplying, we need to convert this load into UDL. How we can convert? We can convert this load by UDL by multiplying the panel length. Load per unit area acting on the roofing multiplied by purlin spacing. That will be UDL load. So I will explain this and then I will continue in the next time. But here I need to explain. Okay, just here, let me add some line for your clarity. Okay, here, uh, this purlin and between this purlin, we have to use gravity load. In gravity load, we have to take the horizontal distance between these two top joints, which is called the panel length. So on this panel or on this purlin, we will design the interior purlin and the same purlin will be used for the exterior. Actually, load is acting in this segment. Half of the panel load is coming on this panel and half of this uh, portion load is going to the, or this panel load is going to the other purlin. But this purlin is surrounded by both sides. It means that this purlin is having the load from the half of the panel length from the one side and half of the panel dimension on the other side. So total width supported by this purlin is equal to P. P by 2 on the one and P by 2 on the other side. So aerial load multiplied by this width P spacing of this purlin or panel length. So we are converting UDL load, the distributed load to the UDL load, like here. So next time I will start from this point number H, and I will explain all the other design criterion, and then we will carry out the purlin design. So today inshallah I will send you the detail of your truss, geometry and height, the loading, so that you can start uh, computing the panel load for your truss and also start performing the unit load uh, gravity analysis and uh, wind load analysis for the unit load. So for load wind acting from the right side and left side. So in the meantime, if you are having any question, so you are welcome to ask the question. So please use the raise the hand option. So 2016, just I'm taking your question, uh, Hassan, I will take. Okay, 216202, are you there? 2016 202. 2016 202. So you are absent. So I'm recording all. 2018 56.
Yes, sir.
Okay, good. You are there. Today is 28 4 2016. CIV 202 is not there. Abdul Hasib Ahmed, are you there?
Yes, sir.
Okay. Yes, Hassan Ali, what is the question?
सर बस वो यही पूछना था कि सिर्फ एक्सेल पे कैलकुलेशन करनी है, सैप पे भी इसका क्या बनाना है, इसके बारे में समझ नहीं है।
यार तो तुम्हें कुछ नहीं समझ आई। यूनिट लोड
नहीं
टू
सर, वो
ग्रेविटी,
जो सैप आप
बता
सैप
रहा हूँ
सॉफ्टवेयर पे कह रहे थे।
यार बता रहा हूँ जो आपने the analysis that you need to perform for the unit load, you have to perform three analyses of the truss. One for the unit gravity load, one for the unit wind load acting from the hinge side, and one for the unit wind load acting from the roller side. So these three analyses, it means that if you are having 30 members, so it means that you need to apply the load at each panel point one, and then you need to determine the member forces. So that you can perform the analysis by manual calculation. Manual may take a lot of time. So I told you that there are many online forums are available. You can perform the analysis for the unit gravity load and wind load either on SAP. I have given you the example of software Sable, or there are many software available online. Just write down maybe free online trust analysis software or analysis of trust analysis software. You can download, you will have lot of tutorial available. It will be quite easy. Just you need to construct the trust in the software, and then you need to apply the unit joint load. When you will apply, then you will have the member force for each gravity load. So it is up to you. So if you will have the forces from this unit load, then you will be able to compute this table, because in the first three columns, member force due to the unit gravity load, and member force due to the, for example, wind load acting on the inside and roller side. So how you will fill up this column? So you need to perform the analysis, either manual calculation, SAP, or any software. So I will leave now student independent. You need to learn the thing by yourself. You can learn easily. If you will have any problem, then you may contact me. Okay, got it? Personally?
यस सर, यस
Okay,
सर।
Hamza,
सर
what
ये
is the
एक और भी
Hamza?
सर
Okay,
ये
just wait for a while. Hamza will ask the question. Interior truss only for interior. Interior only for one. I will mention. Okay. Yes, Hassan Ali, what is your question? Ask me again. Hassan Ali.
वो बस ये यही पूछना था, ये जो सर जाहिद अहमद सिद्दीकी की बुक में 1.2 और जो डेड लोड उसके साथ कॉलम 2 को मल्टीप्लाई किया, लेकिन जो आप बता रहे हो उसमें कॉलम 3 है।
यार उसको बात सुनो मेरी, उधर कॉलम कौन सा, इधर कॉलम कौन सा है? उधर लेंथ वाला कॉलम है जो कॉलम का कंसेप्ट, कॉलम नंबर को छोड़ो, तुम कॉलम में मिस हुए, इसका मतलब तुम कंसेप्ट ही नहीं सोच रहे। कॉलम में जो भी है आपने देखना उसको, यू हैव टू मल्टीप्लाई विद द कॉलम वेयर द यूनिट ग्रेविटी लोड एनालिसिस गिवन, then you have to multiply with the column where the windward load analysis is given. You have to multiply with the column where the leeward wind load analysis is given. That column number may be any. Here, because
Yes,
in
sir,
Dr. Zaid Ahmed Sahib's book, the length column is not available. Is there any length column available? Let me know.
यस सर, लेंथ कॉलम अवेलेबल है।
अच्छा, तो उसको देख लेना कौन सा है, बाकी आपको समझा दिया, आप उसको कर सकते हो। जस्ट सी हियर।
ओके सर, ठीक है। बस ये
नहीं, जस्ट देखो ना, आप इसको अंडरस्टैंड किया करो, आप चीजों को बस याद करने की कोशिश कर रहे हो। हियर दिस कॉलम नंबर 3, व्हाट इज दिस कॉलम नंबर 3? यूनिट लोड ग्रेविटी एनालिसिस। ओके, हियर this column number 3 I have to multiply. Why this column number 3? Because in column number 3 I have given the unit wind load analysis. The column number may be different on different book. Here, what is column number 4? P 1.33, because I have provided the wind load analysis from hinge side, and when the force wind is acting from the hinge side, so roller side will become the leeward. So here leeward factor is multiplied with column 5, and then if the wind is blowing from the roller side, then this will become the leeward side. So that's why here the column number 4 is coming here, and here if the wind is coming from roller side, so column number 5 will become the windward side. You need to understand this column 4 and 5, these are just number, because I could not write this complete sentence. So rather I am writing this column number 4 and 5. That number could be different. And I told you that you have to add this 4 column again, because these 4 columns are for PWW1. Then you have to add this 4 column again for PWW2, because we are having 2 windward load depending upon our orientation or the inclination of the rudder. ठीक है, थोड़ा सा ना चीजों को यार अंडरस्टैंड किया करो। डजंट मैटर, you can ask me the question at any time. Do not hesitate to ask the question, otherwise your concept will not be clear. Yes, anyone is having question? Anyone? Ayan, are you there? Ayan.
Yes, sir.
Okay, good. Miss Pereira, are you there in Sri Lanka? Pereira?
Yes, sir. Yes, sir.
Okay, okay. Hassan Zain? Hassan?
Yes, sir.
Hassan Sajjad?
Yes, sir.
Hubab? Ahsan?
Yes, sir. Yes, sir.
Miss Laiba, are you there?
Yes, sir.
Mubin Hussain?
Yes, sir.
Usama Rashid?
Yes, sir.
Rakib, Rakib Aruj.
Yes, sir.
ये रोजी कौन? रोजी 74200.
Yes, sir.
Zunair, Zunaira or Zunair? 102.
Yes, sir.
Okay. So, inshallah, we'll start the lecture next time. So, in the meantime, in the night, I will send you the instructions or the data for your panel load calculation or table of the forces. So, inshallah, see you next time. Allah Hafiz.